Hi guys, welcome back to another Unity tutorial. My name is Devin, and today we're going to be continuing where we left off with our platformer game. Today we're going to add in an enemy with simple movement AI, where it'll move to one edge until it detects the edge, and then it'll flip around and move back to the other edge, just going back and forth forever until you kill it. So without further ado, let's get started. We started this tutorial series in Unity 4.6, but now we are in Unity 5. And there has been one thing that's changed. If we go to our player script, you'll notice that I have where we get our myBody variable. I changed it from, hang on. It used to be this dot rigidBody2D is all we need to do. That is no longer valid in Unity 5. It was in 4.6, but no longer. Now we need to do a get component rigidBody2D. So if you get any errors, make sure to do this. And I've updated this code on my website too, so you can find the solution there. Also, Unity has this assets run API updater command. If it detects that you have some outdated function calls or something like that, it might be able to auto fix it for you, but sometimes, like right now, for me it's grayed out, so might not work. You might need to do it manually, but yeah, just so you know. Alright, also I've just updated a few of these folders, made it a little more organized for me. And now, let's start with our blob enemy. So I've got this image of the enemy that we're going to have, and when you get him, he'll be set to single sprite. Let's update it to multiple, just like we did for the player. Go into the sprite editor mode, and if we do automatic slice, you'll see in this particular case he's just got one big thing. It's because all of these sprites are a little too close together, so we're gonna have to manually adjust these. And I want the pivot to be in the center middle. So the way that you make new sprite icons manually, or sprite bounding boxes manually, is just left click and drag out a box. Like so, and one for the bottom. And that should be good, except I want that to be in the bottom center again. Next up, I've created a so just a quick tip, if you click somewhere, just like anywhere, and you notice that it's not selecting the thing that you want and instead it's selecting the canvas, that's because the canvas is massive. So if you want to be able to not select the canvas by accident, go up into this layers menu up here, down to where it says UI, and click on this little lock icon. That'll make it so anything on this layer, on the UI layer, is lockable, and canvas is on the UI layer. So now, if I select one of these things, I'll select what I'm actually trying to select instead of the canvas game object. Alright, so I've created another little platform for our enemy to be on. Let's put him up there. He actually looks a little small, so let's increase his pixel per unit to, I don't know, 50 maybe? Yeah, that looks a little better. Alright. So when I dragged in that sprite, it automatically set up an animator and a default animation, just like it did for our player. I'm gonna go ahead and drag those into the animations folder and call this pink blob enemy walk, and that one's fine. Yeah, I'm not gonna get into this guy's animator. If you wanna update his animations, feel free to do so using the lessons that we learned in the previous tutorial that we did for the player animator. But for right now, I'm just gonna leave him at a default walking forever. He's gonna be really simple. So that's gonna be his walk animation. Blip 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 blip. Right, so now let's jump into the player or the enemy script. So in our script folder, let's go to make a new C# and just call it enemy. Now in the enemy script, we're going to want a few things, or a few things that I know we'll need for sure. And a lot of them are going to be the same as what we have for the player. We're definitely going to want a myBody variable and a mask variable. So let's create the mask, call this enemy mask, and then make a rigid body 2D my body. So we're gonna need, before I go any further, let me just explain what I want to do here. So the enemy mask, we're not going to be checking for isGrounded, well we kind of are. We're going to be checking for isGrounded with the enemy mask, but we're not going to let the enemy jump. We're just going to have it be to where it's going to move all the way to the edge, and if it detects that it's not grounded anymore, it's just going to flip and go the other way, and it's just going to go back and forth on this platform forever until you kill it. So to accomplish that, we're going to need that enemy mask, so we don't, so we could do the same isGrounded check that we did for the player and just not collide with itself. We're also going to want the transform of this object, so we can pick a place, pick the transform position to cast down to check the isGrounded bool, and we're going to want to know the width of our player to combine with the transform position, which I will show you in a second, but width. Alright, so now that we have those, let's go ahead and cache them. So my trans, this dot transform, my body, we're gonna get this dot get component rigid body 2D. Put a semicolon there, whoops, and my width is going to be the width of the sprite. So essentially what I'm going to be doing is I'm going to use my trans to find the position of this guy, and then I'm going to use the width of the sprite to find the very front edge of the sprite, and then from there is where I'm going to cast down to see if we're still touching the ground and if we should flip directions or not. So to get the width of the sprite, we need to get the component, the sprite, whoops, not in parent. We need to get the sprite renderer component, sprite renderer, and then we want to get the, not the extents, it's called bounds dot extents dot x. So that's going to give us the width of our sprite. Now that we have those set up, we can start moving our player, or our enemy, and do the isGrounded checks. But I'm gonna want to do that in the fixed update, not the regular update, because we're gonna want to do this on the physics game time, not the rendering game time. So first off, let's just have him always move forward. And we can do that by saying get a new vector2 called myvel for my velocity, and that's going to equal my body dot velocity. And then we're going to adjust the myvel dot x to move at a rate, which we should have a variable for. Let's call it public float speed. And then we'll reassign that back into myBody.velocity. So this is just going to adjust the player, or the enemy, I keep saying player, it's going to adjust the enemy's velocity to just always be moving at that speed horizontally. Alright, next up, we're going to want to do that isGrounded check that I've been talking so much about. So before we do the check, we're going to want to create another vector2 for the Linecast position to find out where we want to cast this line from. And that's going to be myTrans.position minus myTrans.right, and multiply that by myWidth. So what this is going to do is it's going to find the enemy position and then go over, not to the right, but to the left of the enemy by its width. So position right there, which is actually going to be down here because we put the pivot at the bottom. And then it's going to go not to the right but to the left, because that's where his eyeball is, by his width amount. So it should be right at this little blue corner right here. So next we're going to take that and use it in our isGrounded bool. Actually, before I do this, let's just do a debug just to see, just to make sure that I'm putting this in the right place. So debug.draw, whoops, draw line, and we're going to want to start at the Linecast position, and the end is going to be the Linecast position plus a vector2 dot down, which is just 0, -1 vector. Yeah, so let's just see where that line is actually going. We're going to need to put that script on our enemy, and we're also going to need to give him a collider 2D and a rigid body 2D. So let's hit play, and we can see that there's this little line right here, exactly where we want it to be. And his animation is actually a little freaky fast, so I'm gonna decrease it, maybe 8. Yeah, that's better. Okay, let's go back to here, and now that we know that we're drawing it in the correct place, let's go ahead and actually do the Linecast for our isGrounded boolean. So isGrounded is going to equal this exact same Linecast. So it's gonna, we're gonna need to do physics 2D dot Linecast, and it's going to do the exact same Linecast that our draw line is doing, except we're going to want to add in our layer mask so we don't, so this Linecast doesn't return true when the Linecast collides with the enemy collider. We want it to only return true if it's colliding with anything other than the enemy collider, so the ground essentially. So that's all we need. Let me go ahead and comment this real quick. So now let me set this speed to something so it's not going to make him sit still. So now we should have it to where he's always moving forward, and he's checking to see if there's ground in front of him, but we're not actually doing anything if there's ground in front of him or not. So next we're going to need to check if he is not grounded. Whoops. Then we're going to want to flip him. And how are we going to flip him? Let's see. If we hit play, we can see that this line is always being cast in front of him, and that doesn't change when you scale him, so we can't flip him by scaling him -1 in X. Instead, we're going to have to rotate him, I believe in Y. So there we go. As we rotate him, you can see that his forward vector does change. So that's what we're going to have to do. We're going to have to rotate him 180 degrees in Y when we want to flip him. So if there's no ground, turn around. So in here, we're going to do kind of what we did for this, where we cached the velocity, but instead we're going to cache his rotation with a vector 3, because we're going to need the vector 3 for his transform. And we're going to use the current rotation, which I'm just going to shorten to currot, and that's going to equal myTrans dot Euler angles. So that's the X, Y, and Z that you'll see up here. And then the current rot, we're just going to want to add, or the current rot dot Y, we're just going to want to add 180 degrees to it, and then we'll reassign it back in here. So now what we should see, if we hit play, is he will move to the edge. Whoops. Okay, the reason why he's doing that is because our enemy mask is set to nothing, we want to actually set it to everything except the enemy, which we don't have a layer for yet. So let's add a layer, call it enemy, and assign him to it, and unassign it from the enemy mask. And also we're going to want to give him some speed. So now what we should see if we hit play is he should move all the way to an end. Okay, he went the wrong way. That means we're going to have to give him a negative speed. Right there. Because right is considered positive and left is considered negative. And since his forward is to the left, we have to go negative. So here we go. He should go all the way to the edge, find that there's nothing, and whoops, he still falls off. Oh, it's because this velocity is in world space. We're not using the myTrans.right vector, so we need to do that. Let's go ahead and say myTrans.right .x, because x is the only one that we care about, and multiply that by speed. So now he should always move in the correct direction. So here we go, we're moving forward, flip, move forward, and he should just keep flipping like that. So other than that, we're probably going to want to have him turn around if he hits a wall as well, not just if he detects no ground. So something like this should cause him to turn around. But it doesn't, because we don't have array checking to see if he's blocked that way. So let's go back to our script. And not only do we want to do an isGrounded check, but we're also going to want to see if he is blocked. So isBlocked, we'll do a Linecast from Linecast position, and we're not going to want to do a vector2.down, we're going to want to take his forward vector or his right vector. So let's do that. Our left vector actually, since left is his forward. Except we can't do that directly because his vector3.right is it's a vector3, and we're trying to add it to a vector2, which is the Linecast position. Ordinarily we can't do this, but I've made a previous tutorial on how we can do this. If you go to my website, devination.com, or watch this extension methods video, we will create this script right here, which creates a 2vector2, let's zoom in so you can see that better, creates a 2vector2 function that the vector3 class can use. So it'll take a vector3 and convert it to a vector2. All this is explained in this video, so be sure to watch that. So let's go ahead and put this script in our project so we can use it. So I'm going to say create new C# script, extension methods, open that up, and just paste it all in there. That could go over. So now if I go back to here and type in myTrans.right.2vector2, we should be able to do that. And let's go ahead and do another debug draw line for the isBlocked boolean. Linecast position minus that. And we're probably actually going to want to make it a lot shorter, because this is going to be a this vector is going to be 1 in length, which is 1 unit, which is pretty long. So let's just multiply that by 0.02, let's say. Both of those. And down here where we see if he is grounded, or if he's not grounded, then we turn around. We're also going to want to do that. Or if he is blocked. So if there's no ground, turn around. Or if I'm blocked, turn around. Alright, let's see if that works. And for speed's sake, I'm just going to move this guy over here since he travels that direction first. Oh, you can see he is projecting his little line out there, but the collider is actually a little too high for where this collider is. So like the line is right here, but the collider is right up there. So instead of projecting it from this corner, we're probably going to want to project it kind of from the center, or a little higher of this guy. So back in our script, let's get another float, and we'll call it myHeight. And we're going to do the same thing up here, except since we're using the sprite render component twice, I'm going to make another temporary variable right here for it, so we don't need to look it up twice. Sprite render mySprite equals that. And we can replace that whole thing. Alright, so we get myWidth is the extents.x and myHeight is the extents.y. So boom, boom, boom. And let's go ahead and take this Linecast position and add onto it a vector2 dot up vector times our myHeight. So now, instead of both sprites being cast from right here on this little corner, they're both going to be cast from right here. Since we're using a vector1 or a vector2 dot down with no multiplier like this, the downcast is going to be 1 unit in length, which is still plenty of length to detect the ground. So it'll be fine if we cast both lines from up here. So let's give that a go. Oops, we got an error. There's a vector3 in there. Where are you? Ah. And let's convert that to a vector2 and a vector2 there. So it wasn't giving us that error before because we didn't explicitly have a vector2. We were just using two vector3s and saying, hey, you're going to be of type vector2 right here. And Unity will actually implicitly convert that for you, but if you explicitly add a vector2 and a vector3, then it's going to throw an error. Alright, so that should be fine. And let's give it a go. So there he goes, he bounces back and forth. And in fact, we could probably make that line a little longer. Let's go ahead and do 0.5. And you know, you can adjust that to be whatever you want, but just look at how far the line is casting and see if that works for your particular case. So that is it for now. Thanks for watching. Be sure to like and subscribe if it was helpful. Be sure to follow me on Facebook, Twitter, Google+, all that stuff. I'll always update those media outlets whenever I publish a new video. Also go to my website to get the updated code for this lesson. And if you haven't watched the previous videos in this series yet, where we added in player movement and animations, be sure to do that. And don't forget to subscribe so you can watch the next part of this series where we'll add in player and enemy combat. Thank you so much again for watching, and I'll see you next time.